Hi everybody, this is Nikki from Educating Now, and I just wanted to do a quick little vlog on a concept that may not take a whole lesson, but is certainly worth talking about during lessons and maybe even doing a little bit of exploration as I'll show you here. And this is this idea of when we multiply by multiples of 10. And so often, whether it's explicitly taught or students develop the rule by seeing the patterns on their own, what we often see students do and what I hear them explain is when they get something like this, they say, oh, this is easy. We just go 4 times 3 is 12, and then I add the 0. So this does work with whole numbers really well. The problem with it is twofold. Firstly, students are skipping over the really important understanding of place value. And that understanding of place value is also what is linked to developing number sense. So we don't want to skip over it. And it's great for them to see these patterns and to see these kind of rules that they've generated, but they also need to understand why they work and be able to explain them mathematically. And the second problem is that this does only work for whole numbers. So what I see in the middle school level is students use this same idea totally incorrectly. So here's an example that they might get in grade 6, and now all of a sudden they're multiplying not by whole numbers, but they still use the same rule. So when I give this to students and I say, what do you think it is? They're quite confident, and almost all of them give me this as their solution. And of course we can see that 3 and 20 hundredths is actually the exact same value as 3 and 2 tenths. So they've misused this rule. So instead of teaching this by rules, let's teach it with a little more understanding. And the other thing, and I actually do this with my students, is when I ask them how they do this, if they say, oh, well, as I explained earlier, you just go 4 times 3, which is 12, and add a 0. I act deliberately obtuse. So if I'm writing this on the board, I say, okay, so 4 times 3 is 12, and then I add a 0, which is 12. And the students go, no, 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 you add a 0. And I say, oh, yes, I did add a 0. I did 12 plus the 0, which is 12. And then we talk about when we add 0 to a number, it doesn't change its value. And the students get a little bit flustered, and eventually they say, I just mean to add a 0 onto the end to make it 120. And that's where I want to stop them, because adding a 0 does not change 12 into 120. What it does is changes 12 to 12. It doesn't change it at all. So I ask them, what is the mathematical operation that changes 12 into 120? And what I'm looking for is they understand that it's 10 times as large. And the operation of multiplying by 10 is what changes 12 into 120. Now, looking at it abstractly like this, it's not going to be obvious to students. So we can use our base 10 blocks to help them make this a whole lot more sensical. I put all of my manipulatives up on here, but if you just start here, I ask them to start with, show me 2 groups of 3. So 2 groups of 3 wholes, and we're going to use these little ones as whole numbers. So students will show something like this. They've got 2 groups of 3. What's the answer? It's 6 wholes. Then I ask them to show me with their blocks 2 groups of 30. And I ask them what is similar about this answer to their first answer. So what's similar about 2 groups of 3 and 2 groups of 30, and what is different. And when students see it this way, they start to understand that what's the same is they still have 2 groups of 3 blocks, or a total of 6 blocks, but the difference is the place value. These blocks are 10 times as large as these blocks. So the answer, 60, is 10 times as large. And we can continue on the pattern. Now we can look at 2 groups of 300 and see here that we still have 6 blocks, but these blocks have a place value of 100 each. So the total value here is now 600. So we still have 6 blocks no matter whether we're doing groups of hundreds, tens, or ones. The difference is in the size of the blocks or their place value. And you can play around with this and look at the difference between, this right here is showing 2 groups of 3, 2 groups of 30, two groups of 300. You could also look at the difference between two groups of 3, 20 groups of 3. And if we started to do that, students would play around with their manipulatives and see that you could still represent it in a similar way. You could look at 10 groups of 3, and that would be here, and so 20 groups would be those two together. So using the base 10 blocks will really help them to understand, as well as using that language. So we want to move away from non-mathematical rules like add a 0 and expecting that to make the number 10 times larger, or adding 2 zeros, when really what we're doing is making the number 100 times larger, and instead have students understand what's really going on. That way, when we start using these base 10 blocks for decimals and we start changing the place value, we eliminate those mistakes that I showed you earlier, and students have a lot more conceptual understanding that really what we're doing is changing the place value. And we're not moving the decimal per se, we're changing the place value, because as soon as you have 10 of any one of these size blocks, you immediately have the bigger size block. So as soon as I have 10 ones, that's equivalent to a 10. As soon as I have 10 tens, it's equivalent to 100, and so on. So this is really valuable when you're looking at introducing double-digit multiplication, and you want students to be able to quickly and effectively multiply things like 4 times 30, or even 40 groups of 30, but with understanding and with a really deep understanding of place value. So these blocks are a great way to introduce that, or have a little mini lesson before you jump into using this idea for larger number multiplication. Thanks so much for joining me, and have a great day.